In this video, we're going to take a look at how we can build a phone authentication system. So for this, I have this demo application. We can create groups, we can delete groups, and all of this is done with Next.js and React. Now, it doesn't matter what framework you're using, as long as you're using React, this is transferable to pretty much anything. So if I come here to my top right, I have this user drop-down menu, and here I get access to settings. Now, if I open this up, this opens up a modal, and these are for the settings for this current logged in user. So here we can see the name of the user, so Wombat, then the email, and then we have the phone number. So you might want to store phone numbers for two-factor authentication, or you maybe want to send SMS messages, and so you need to store the phone number of the user. So for this, we can click here on add, and this is going to open up another modal. And here we can choose from different countries. So we can say United States or Argentina, Bangladesh, etc. And this is all headless, meaning that you can style this however you want. You can change the color of everything. You can change the layout of this because, well, it is headless, meaning it is unstyled. We add the styles however we want. So here, let's keep it as US. And then here we have this placeholder. So if I change between countries or Argentina, as we can see, the placeholder gets updated accordingly. So we're validating the phone number all in the client side. So here I can say United States, and I can filter for the countries. And then I can say 1, 2, 3, and then some numbers. And as we can see, we get real-time validation. So phone number does not match selected country. So if I come here and type in a valid US number, so 202-555 and then 0172, as we can see, we can now proceed with the phone number validation. So once I click on this, as we can see, we get OTP sent, so one-time password sent, and this is the verification code. And we need to do this to make sure that the phone number really belongs to this user and that the phone number exists. Now, this is all hooked up with a backend, so this is obviously designed in such a way that it is as secure as possible, but also provides a great user experience because we get the verification code will expire in 4 minutes and 21 seconds. So if I click, let's say cancel, then click here and update again, as we can see, it didn't send another verification code because it knows there's one pending. And then here we can type in the verification code. So let me open up my terminal here. And as we can see, if I scroll down, we have the phone OTP for this phone number. So 6627. So if I type this out, click verify, as we can see, the phone number is now verified. And we can now see it here, and we can update it as well. So we can start the process from the beginning again. And if I come here to my database, and then come here to users, as we can see, the phone number has been successfully stored in the database. And it is in the international format, so it includes the country's code. So in this case, it's 1 for United States. But let's actually look at the validation. So what happens if we type in the same number again? So this one, if I click on update, the new phone number cannot be the same as the current one. But now let's say we want to change the phone number to one that is valid, so one that's different from this one. Now, as we can see, we also have this verified badge as well. The phone number has been successfully added. But if I come here and change this to this other phone number and then click here on update, as we can see, we get OTP sent. But what happens if we try abusing this? So we have someone that is trying to exploit our verification system and they want to brute force their way in. That means trying as many combinations as possible. Well, for that, let's say 111, verify, invalid, then another one, we get invalid. And what about this one? We get invalid. And if I try one more time, we get rate limit exceeded. And in fact, this rate limit, if I open up Redis, is set up for the same time for the verification code. So as we can see, we have the rate limit and the time to live is 4 minutes. And what about the one-time password? So the code, this one is also set for 4 minutes. So at this point, there is nothing that you can do here to brute force your way in. You will have to wait the 4 minutes and then the backend will generate another code. And so you only have 3 chances to get it right. Now I want to be clear and say that this is a proof of concept. Of course, security-wise, there are some things that should be improved, such as checking the IP, making sure that the person trying to add a phone is in the same region or place as the one that created the account. So geolocation analysis, those things are done by providers that give you these phone verification systems. But since we want to learn from this, we want to roll out our own system, then this is a great learning experience nonetheless. So now let's expire this. So let's come here to the phone OTP and let's modify this and let's change the time to live to be 20. And if I save this and then come here, as we can see, we get will expire in 0 minutes and 15 seconds. Now let's quickly wait the 10 remaining seconds and let's see what happens. As we can see, we get this button telling us resend the verification code. So if we do this, as we can see, we get OTP sent. So again, we can try 3 times. So if I come here and get rid of this rate limit, delete, and then come here to this code, copy this code, and then paste it here, then click on verify. As we can see, we have successfully changed the phone number. Before taking a look at the code, let's take a look at this diagram so that we can get a high-level overview of how everything will work. Now this is for the backend because always with the frontend, there are 1,000 different ways to do it. So let's focus on the actual logic. So here we're going to be using Redis and PostgreSQL. Now you might be wondering, what is Redis for? Well, we're going to be using Redis to store the verification codes. And the reason is because verification codes are short-lived, meaning that they are temporary. If you were to store them in the database, that would mean that you'd have to set up a cron job or something that is going to periodically remove all of the expired verification codes. And that adds a lot of complexity. So to avoid that, we can just use Redis, set an expired time for the key, and call it a day. It is going to automatically remove the expired keys, so we do not have to worry about that. Now as for PostgreSQL, well, we obviously need to store the phone and when the phone was verified. Now as for the functions in the backend, well, this is pretty basic. All we need is a function or an endpoint for sending the OTP. That means that we hit up Redis, we store the generated OTP, so one-time password. So it could be 4 characters, so 4 numbers or 8 numbers, whatever you wanted there. And then the frontend would move to the next step where the user can input the OTP they received in their phone. So for this, you'd also have to have another endpoint for verifying the verification code. So the user types in the code, and when they click on submit, the backend is going to hit up Redis. It is going to extract the value, so the OTP, and then it is going to compare that value with the input from the user. And we also need a third endpoint to get the time to live, so when the key in Redis will expire. And the reason we need this is so that we can show that counter that says 5 minutes and 3 seconds remaining, for example. This is just for the user experience, although it is not completely necessary. Now let's quickly go over the libraries we're going to be using for the frontend and the backend. So first of all, I'm using shadcn so that we have complete control over the styles. We're going to be using the combo box, so this component, for the select for the country code, we're going to be using the input component, and we're going to be using the button component and the dialog component. So if you want, you can go ahead and install them, but remember, you can find the repository in the description, so you can just check it out. Next, we're going to be using Luxon. Luxon is a library for dealing with dates and times in JavaScript, and it is extremely powerful, and it is my favorite date library. So as you can see, you use this datetime object, and then you can say now, and then you chain any methods you want, and it supports pretty much all of the formats. It has internationalization, parsing, formatting, etc. Next, we're going to be using libPhoneNumber.js, which is a port from Google's libPhoneNumber library. Now here in the description, it says Google's libPhoneNumber is an ultimate phone number formatting and parsing library developed by Google for Android phones. It is written in C++ and Java. And while it has an official auto-generated JavaScript port, that port is tightly coupled to Google's Closure JavaScript framework, and when compiled into a bundle, weighs about 550 kilobytes. So this is just a port that is more minified. So it has a smaller footprint of only 145. So this is for the validation for phone numbers, so that we can make sure that both in the front end and the back end, the user is inputting a valid phone. In terms of the formatting, not that it actually exists, that is done by our backend. So this is why we have the one-time password, so that we make sure that that phone is 1, valid, and 2, that it belongs to that user. We're also going to be using IO Redis, which is a Redis client for Node. So this is the client we're going to be using to perform all of this communication with our Redis cache. And that's pretty much it in terms of libraries. We're going to be using Next.js, but if you use Remix or just vanilla React, you can copy and paste the code there. It doesn't matter. We're not going to be using any specific feature to Next.js. So for this, let's first of all take a look at the schema, so at the database schema. So here I just have this user table. We have some columns such as name, email, created ad, but the important part here is the phone number. So this is optional, so this column is nullable, and this is set to be unique. Now you can get rid of the unique, because in fact some applications let you have multiple accounts with the same phone number. That depends entirely on your project requirements, but in my case I just set it to be unique. And then we have phone verified, which is a date time. So this is a date column with the time zone, and this is also nullable. Why? Because, well, the user may not have a phone, so it makes sense that this is not required either. And this is pretty much about it, nothing special. So now let's take a look at the backend. How did I achieve this? Well, if I come here, and you can find the repository in the description, by the way, if you want to check it out, play around with it. If I come here to the server directory, and then come here to routers, we have this user module, and then we have this phone module. Now, this user module is simply using TRPC, so for that end-to-end type safe communication between the client and the server. But well, you can pretty much copy this logic and paste it in any other backend framework, so Nest.js, Adonis.js, whatever. And here we just create a TRPC router, and we pass in the phone router. So this is all for the collocation. Why? Because, well, everything pertaining to the phone pertains to a user. So this is why it's underneath the user router. And here you can add any other procedures you want. So if I come here to the phone router, here we have the verify OTP mutation. So it simply takes input, which is the phone. So it contains the phone number, which is the internationalized phone, and it also takes in the phone country code. So here we say input, we pass in this input. So again, this is simply the phone, and here we perform some validation, but for now let's skip this. So here we have again the phone number and the country code, and then we rate limit this to prevent abuse and brute force attacks. So we say await rate limit, we pass in the session, so the rate limit applies to that particular session, so the user that is making the request. And then we have 3 maximum requests per 5 minutes. So you can only make 3 requests per every 5 minutes. and then we construct the unique ID. We pass in verify phone OTP, and then we pass in the phone number, so that this is also only limited to this phone number. So if the user were to try and verify their phone number, they got rate limited, but then they noticed that their phone number was wrong, and now they need to change it, so they change it, and then they get the verification code. Well, that rate limit will be for that particular phone number, so they do not get locked out from using any phone number if they exceed the max requests, obviously. And then we just call in next. Now this function, and you can in fact find a video in my channel where I explain how all of this works. Well, it is simply going to take in the counter with Redis and will make sure that the number of requests do not exceed the maximum requests, so these ones. And if it exceeds, we just throw a gRPC error, too many requests, rate limit exceeded. That's pretty much it. And then we have the mutation, we take in the context and the input, and we invoke the verify OTP method in the phone service, which we're going to take a look in a bit. And then we have send OTP. So this is for requesting the one-time password. So now that I think about it, a better name might be request one-time password, but well, this works. And here again, we rate limit to avoid someone requesting a lot of one-time passwords to try to brute force their way in. We construct it as this one, so pretty much the same. And then we have the mutation, and we invoke send OTP, and we pass in the input and the session. And finally, we have this query, which is get one-time password time to live. So this is for showing here the time to live. So if I click on update, as we can see, we have this timer. So this is simply going to check from Redis. So let me actually come here. It's actually pretty basic. Simply get the time to live. So Redis.time-to-live, and we pass in the Redis key. As simple as that. And well, this is going to return the time to live in seconds. So as we can see, get the time to live for a key in seconds. So that's how we can get this timer. And in fact, this is the great thing about using Redis, is that, well, we have control over this data. If you were storing the OTPs in a backend, it would make things so much more complicated. It wouldn't really make sense. So Redis is the perfect candidate for this, especially because Redis is a cache, and a cache is for short-lived data. OTPs will only live for 5 to 10 minutes, so it doesn't make sense to store it in a database. And all of these are the methods. So this is the whole backend. Now what about the methods themselves? Well, let's start with sending the OTP, so requesting the OTP. So here we take input, so send phone OTP input, which again is just the phone number and the country code, nothing more. And we also take in the session, so the session contains the email, the ID, name, image URL, phone number, phone verified, and the session token. And all we do is say this.getPhone OTP Redis key. So this is a helper function that is going to construct the Redis key for us. So we pass in the phone and the user ID, and as we can see, it follows this format. So phone OTP, then the country code, then the phone number, and finally the user ID. And then we check if we have already sent the OTP. So we say redis.exists, and we pass in the Redis key. Now this is going to return a number, so I believe it is 0 if it doesn't exist, or 1 if it does, or maybe -1 and 1, but I'm not entirely sure. You can consult the documentation for that. And by the way, I'm using the IO Redis library for Redis, for the Redis client. And then we say exists, and we check if it's 1. If it does, well, we just throw an error saying phone OTP already sent. Otherwise, we generate the verification code. So this is going to be a string of 4 characters or 4 numbers. And then we say await redis.set. We pass in the Redis key, we pass in the 4-digit OTP, so key value per, and then we pass in the time to live, so the expiration time, which will be 5 minutes. So plenty of time for the user to verify their phone. And then here I have this commented out because, well, this depends on you. And this is for the SMS service. So you'd have a helper service where you can simply say await SMS service .send message. Then you would say to, and then phone number, and then you would send the message with the data. So your phone OTP is this one. And then you would log it for development purposes. And well, if the SMS service threw an error, so maybe it couldn't send the message to the phone, or perhaps the phone number is invalid, then you would just delete the key and invalidate it right away. And then after this, well, you can just return nothing because this is all of the logic for this method. You only need to send the OTP. If there were no errors thrown in the process, you can be rest assured that the OTP was sent successfully. But in my case, since I did not integrate this with an SMS service, all I did was log this for development purposes. Now, what about verifying the verification code? Well, this is very straightforward. All we need to do is get the stored value. So if it wasn't found, then the user either never requested the OTP or, well, it has already expired, so the 5 minutes have already passed. And then we just check if the OTP from the input, so what the user typed in here, is the same as the one stored. And if not, we just throw this error. Otherwise, we can proceed. And all we do here is update the database. So here, user repository.update user phone number. We pass in the user ID and we pass in the phone number to be stored. And then we can delete the key because, well, it is no longer valid because the user just validated their phone number with this OTP. And then we log this. So for development purposes again, and then we return the new user information. And the reason we do this is because we need to update the data here in the client. So when we submit the verification code and everything went okay, well, we need to update and tell the client that this will be the phone number. So for that, I just return all of the user info and we store that in our session store, which I'm using Substant for this, which simply contains the data for the user and then a status, so authenticated or unauthenticated or loading. Now, if you're interested in implementing your authentication system with Next.js, make sure to check out my other video. I have one on that as well. Now, what about the internals of this? Well, I just say await db.update table. We pass in the users. We set in the phone number and phone verify to be now. And then we say where ID is equal to the session ID. So this one right here. And then we check for errors. So we check if the phone number is already in use. So we catch a database error. So for this unique violation. And if not, if the error is something else, we just throw an internal server error. And then we get the updated user. So await this. .get user by ID, we pass in the user ID, and then we say bypass cache and include sensitive info. So if I come here to this method, we just have some basic logic, which is going to cache the user information in Redis. So we do not hit up the database every time we want to get the information for a user. So at first, if there's no data in the cache in Redis, we hit the database, ask for the information, and then we store that in Redis. But well, this goes out of scope for this demonstration. But again, if you want to see how all of this is done, make sure to check out my other video. And again, all we do is return the updated user. And that's pretty much it. So nothing fancy. And here we also return it from the service, which is going to be returned by the router, which our client will be able to consume. So as we can see, the backend is very basic. There is not a lot going on. Now, if you were using a database, it would make it way more complicated, that's for sure. But with the power of gRPC, this all becomes very rudimentary. So now let's take a look at the front-end implementation. So how can we hook this up in the front end? So if I come here and if you check out my repo, I have this header under components, under lib, under application. So this is the library directory for the home page. And if I come here to this header, we have, let me close all of this, we have this. So this is going to render the title, so the application name. And we also have these two. So we have notifications. So for group invites, if you want to check this out too, well, make sure to check out my channel. But we have this drop down menu. So this is the user drop down menu. And if I come here, which is under header, so everything is collocated, we have this logout mutation. So for logging out, pretty self-explanatory. But we have this first drop down menu item, which is going to be for the settings. So this one right here, which if I click is going to set open settings to be true. And here we render the settings modal, which again is collocated with the user drop down menu. And this is simply going to take in the open and unopen change so that we can control the open or the show state of this modal. And then here is where the magic happens. So here we use this use session hook. So if I come here, again, this comes from the session store, which is a substance store, but we have this custom hook, which is simply going to take in options. So the options is a possible callback for an update. So this is a way to synchronize something. So maybe you want to listen for the update of the session. So maybe when the name is changed, well, you can invoke or pass in this function, which is going to be automatically invoked whenever you update the session. So again, this is a listener and we pass in the session store data and then the status, which again is authenticated or unauthenticated or loading. So nothing crazy. This is all pretty basic. And so we simply check if the phone number is different from undefined. And we also check that it is different from null because, well, since this is using optional chaining, that means that if the data property doesn't exist, then we get undefined back. But phone number itself can be null. So that's why we get string or null or undefined. So we check for these two cases explicitly. And then we define the state for showing the phone modal. So this one, when we click on edit or add a phone number, we get this modal. So this is controlled within the settings modal. And that makes sense because, well, this is the parent. This one, which is the parent, houses this other modal. And then we have handle phone modal open change. And the reason I'm doing all of this logic right here, so if the new value is true, so if we're going to open up the phone modal, so this one, so in this case this is true, then it is going to hide the current modal, so the settings modal. That way we do not get those stacked modals where if I were to click on these we get another modal and we still can see the settings modal underneath that. Well, we're controlling them and making sure they are synchronized. So when we open the update phone number modal, this one will be hidden. So we get that nice user experience. And then we render update phone modal. So again, this is the modal for updating the phone number. And then we render the modal itself, which is going to be for the settings. So this one. And we pass in the title, the description. We have the name, so session.data.user.name, same with the email. And then here we have this phone number part. So this one. So we check has phone number. If so, then we know that it is verified. So we say verified. So we render this badge right here. Then we render another span with the phone number. So if the user has a phone number, we just parse the phone number. And for this, we're using the lib phone number.js library, which, if I search for it, is a Google library, which provides great utility functions for validating and parsing phone numbers. So this is the library we're using to make sure that the inputted phone number is valid. So in the format we wanted, and also, well, that it corresponds to the country code they selected. So if it's United States, it must have the format of United States, but we're going to see how that works in a bit. And then we just format it international. So we get this +1 and then the number itself. Otherwise, we just say no phone number. And then we have this button. so the edit button, which in fact, if there's a phone number, so has phone number, so this can be simplified to has not has phone number. So if the user doesn't have a phone number, then we render this add and the plus icon. Otherwise, we render edit. And this button is just going to open the phone modal. So this one again. So it calls this handle phone modal open change, which is going to do this bit of logic right here. And that's it in terms of this modal. But now what about the update phone modal? And this is where the complexity begins. And in fact, this is harder to implement than the backend. So here we're using useForm from React Hook Form, which is a great library for managing forms with React. We provide in the default value, so we have phone and phone number and country code. So we initialize it. So this will be initialized to an empty string at first. And as for the country code, these will be countries with codes at 0. So if I come here, which is under this directory here, we have this array that has all of these elements. So this represents each country. So we have the name in English, the continent, the capital, we have the dial code. So in the case of United States, it's +1, then code 2, which is this one, so US. For Colombia, it's CO. For Mexico, it's MX, etc. And then we have the emoji, which renders this emoji right here. So we get these nice emojis. And in fact, if you're using Linux or Mac OS, if you were to open up this website, you would see the flags. Unfortunately, in Windows, you cannot see the flags. So we only see these short names, which are the codes. But again, if you're using pretty much any other operating system, you should be able to see the flags. And then we have the placeholder. So this one right here. So in the case of United States, it's this one. In the case of this one, it's this one. So all of this is manually inputted. We're not using any API to fetch the countries with codes, but this is great because you have the flexibility to add and remove any country that you want. And this is of type, and we have this array syntax. So this is a way to tell TypeScript that this array will not be empty. It must have one element. And this is great, so we do not have to validate if the element exists at 0, because, well, we're enforcing it here at the type level. And then we say we take in as many other elements as we want. So we spread over an array of country with code. So again, here you can add or remove countries if you want. And then here we pass in the SOD resolver and we pass in the send phone OTP input, which in fact this is used both by the client and the server. And if you're in a monorepo, it makes sense to use the same validation logic for the backend and the client. That way they are synchronized. So if I come here to this schema, we have this phone, which is an object again, and we have the phone number. So this is a string, we trim it, and minimum 2, because, well, no phone number anywhere is valid with just 2 characters or less. And then we take in the country code, and this country code is in fact another SOD schema, which is here. So we have create many union, and then we have country codes as type of country codes, and then we have this type right here, which again, similarly to this one, where we say it must have one element. In this case, we're telling it that it has at least 2 elements, and then the rest is dynamic. And then we have the required error and the invalid type error. So this is a way for us to be able to pass into SOD the different country codes that should be supported. So for that, we just iterate over this array, we extract all of the codes from each country, and then we pass it into this helper function, which is just going to return as z.union, and we pass in all of them and we say literal. So the value must correspond to one of these codes in this whole array. And then if I keep scrolling down, we have this refine. So that's why we have this nested property, so that we can use refine. Now, if you're familiar with SOD, you would say, well, just use refine on the base object. Why are you creating a nested unnecessary property? And the reason is because we need to merge it, and you cannot merge one that has a refine at the top level. So that's why we need to nest it one level so that SOD is happy and we can then merge it. And then we have this refine, we get the value which contains the country code and the phone number, so the two. And then we say const phone number is equal to parse phone number with error, which this comes from lib phone number.js. So this takes in the text, which is going to be the phone to be validated or to be parsed. And then we have the default country so that it knows the country it belongs with. So that's why we take in the country code as well, because, well, you may know that some countries share the same phone format. So we need to be explicit and tell it to which country it belongs to. And then we just return phone number that is valid. So if this is true, then we're good to go. If this is false, this is just going to throw an error saying phone number does not match selected country, and we pass in the path to be the phone number. And finally, we have this transform, and this is for us to be able to consume it in the backend. So we take in the values, which again are the phone number and country code, and then we format the phone number to be in the international format, which is this function right here that I created that takes in the phone number and just invokes format international, and then we replace all of the white spaces. That way we get the format in the database with that single string with no spaces with the dial code. So this one and the rest of the phone number. And if I scroll down, we then parse phone number with error. And the reason we do this is because we must pass in to this function the return type of parse phone number with error so that we get access to these methods. So we cannot just pass in a string, that wouldn't make sense. As you know, strings do not have these methods natively. And well, the country code is just the value.country code, nothing more. And then we export the type, and then we have the verify phone input, which must take in the phone information, but also the OTP, which has to be from 0 to 9 and 4 digits. So a 4-digit number. And that's it. So this is for the validation, which we're passing in the SOD resolver. And then we tell the form to validate on change. So every time the user types in, this schema will be run. And then we need to get access to the phone number and the country code the user is selecting. So for a controlled input. So for that, we can say form.watch and we get access to the phone. And same with this, so form.watch and then the country code. So this way, it's as if we were storing this in a use state. But well, this is being managed by React Hook Form internally. And then we say selected country info, which is going to be a country with code. So this type right here, why do we need this? Well, we need this to know the data to render. So if I click on Argentina, we need to know what the dial code is for this select. And we also need to know, well, the flag. And same with the placeholder. So we get access to that here, where we just find the country that corresponds to the country the user has selected. So that's why we say where the country code to, so from each one of these, is equal to the selected country code. And then with this, we can also derive the selected country. So all we're doing here is construct the combo box option. We pass in the label from the selected country info and the same with the value. So this is all derived. So we do not need to specify two different states. That wouldn't be ideal. And then the country options for the combo box, so that we can render all of these options with the label and then the flags. So all we're doing here is sort them alphabetically, and then we map over them and we get the label and the value. And that's pretty much it. And in fact, this is of type combo box option array. And then we have the functions for submitting. So this is for us to type in here, and then we click on update, and it is going to call the backend, and it is going to ask for the OTP to be generated. So here we say send OTP mutation, so api.user.phone, and then send OTP. So this is to request the OTP. And then we have the handle submit. We take in the data, which is this one again. So we take in the phone number and the country code, and then we make sure that the phone number from the data is different from the one they have in the session. If they are the same, we just set a manual error saying the new phone number cannot be the same as the current one. Now this is enforced in the backend, but this is just a safeguard for the frontend, for that user experience, of course. And then we get the cache data and we get the time to live for the OTP. So this is a way for us to check if there's cache data. That means that the user has requested an OTP for the same phone number. So we just skip to the OTP modal and ask the user for the OTP. That's pretty much it. Otherwise, if it's the first time with this phone number, so let's say this is the first time I'm typing this with this phone number and then click on update, it is going to execute this logic, which is simply a toast promise. We invoke send OTP mutation, we pass in the data, and then for success, we show the OTP modal, so this one. And we also set the phone to the data that the user passed in. The reason we're setting the phone is so we do not lose the state. So if I cancel this, since I'm unmounting this modal, we would lose this state. So by keeping it state, we might lose this state. So that's why I'm keeping it there, so that we can maintain the default value to be this one. And then we check the error. Well, if it's too many requests, so a rate limit, we still show the OTP modal nonetheless. And as for the render logic, well, we make sure that we want to show the OTP modal and the deselected phone is different from null so that we can pass it on to the OTP modal. And then we have the dialog for updating the phone number, so this one right here. And we render the form, we pass in the handle submit function, we render the combo box select, and for this I'm using cmdk, so this command right here from a great library that allows you to build these combo boxes. So if I open up chatcn, which is actually the component library I'm using under the hood, and then search for command, as we can see we have this command right here. So this is a combination of the command and the popover component. Now you can find the documentation for this here and how to install it and how to use it. But as we can see, it is pretty much the same as the one I have here. So we render that combo box, which is a wrapper for the popover and the command. And we pass in the button label. So select a country, the default value, empty label, then the options, which is the memoized array, then the selected option, which is derived from the form state, then the placeholder, so search for a country, and then whenever we select for a country, we invoke this function, and we just call imperatively form.setValue, and we pass in the new country.code2. And as for the filter logic, so we can search for a country, this is also done here. So you can take a close look at this in the description where I left the repository. And then we have this phone number input, which is just a controller. So this is controlled. This comes from React Hook form, and we render an input. And this input is just a wrapper for the native input element. So nothing fancy. And then we pass in the value. So again, controlled, and then the onChange. Now this is interesting because using lib phone number as well, we can format as we type. So we use this as you type, we pass in the code, and it is going to give us the formatted value. And so we can invoke field.onChange and we pass in the formatted value. That way, as you can see, this is formatted. It has the corresponding spaces and whatnot. So this is great for that user experience as well. And then we just render the footer, which is the update and the cancel buttons. And the update is going to submit the form, which again is going to invoke all of this logic right here. Now, when we get to this point, as we can see, the OTP has been sent. And so if we take a look at that modal, so OTP modal, which is collocated with the update phone modal, as we can see, we have this use timer hook, and this comes from the library React Timer Hook. And this is a great library that allows you to have this fine-grained UI for timers. So here's how we can achieve the in 4 minutes and 22 seconds. So via this hook, we say the expiry timestamp, and then we say auto start to false. And then we invoke the OTP Time-to-Live query, And then when this is successful, so when we get the time to live, we just invoke timer.restart, and then we pass in the corresponding dates. So we say date.now. So this comes from Luxon, which is a great date library. We say .plus, and then from object, and we pass in the seconds, which come from this query. Which again, if I come here to this procedure, and then to this one, we just return the time to live in seconds. So we get it here, and we just set the time in the timer. Then we have the form, default value to be the phone. We pass in through the properties, and then the OTP is just empty. And again, we pass in the same sort resolver, but this time the merged schema, which is going to validate the OTP. And then we have this verify OTP mutation. So this is for when the user clicks on verify. This is going to invoke this procedure. And if it is successful, again, we get the new user information with the phone number and the phone verified properties, and we just update the session. Now, if there's an error and if it's bad request, so let's say we say 111, which is going to be incorrect, and then verify, as we can see, the OTP has been cleared. And if I scroll down, we have this function, verify OTP. We take in the data from the form, and we just invoke this mutation. So this is very basic. And then we have the send OTP mutation. So this is for refreshing the OTP when we get this button right here. And we do the same, just toast.promise, and then we pass in the phone so that we can send another OTP, which is the same we're doing here in the update phone modal, where we invoke send OTP mutation. So it's the same procedure, no need to create a new one. And then we render the form, we render the OTP input, and this OTP input comes from React OTP input. So we can style it, we can even pass in each render input, so these ones, and we get this great user experience. We can use arrows to navigate through the different inputs, and as you type, it is going to move you to the next square. And if I delete, again, this is going to remove the OTP. So this is a great library as well, and we can give it the styles we want. So it is pretty much headless, since we can pass in a custom input component. And as for the onChange, this is also controlled. So we just say z, so from sud.coerce.number, and then save parse and success. So if it is a number, then we just change the value with the new number. Otherwise, if I type in any other character, it is not going to add anything whatsoever. And then we have timer is running, so we get this great boolean. So if the timer is running, that means that the OTP is expiring. Then we can say the verification code, and this is a typo, will expire in timer.minutes and timer.seconds. And if it is not running, so right now it is not running, so this is false, and the OTP time-to-live query data is also undefined, then we can resend the OTP. So when I invoke this, as we can see, we get the new OTP sent to our phones. And then we have the button for verify and the button for cancel. So this is everything. Again, you can find the repository in the description. Now, if you're interested in seeing more content like this, make sure to like the video and subscribe. I'll see you in the next one.